The question that comes up all the time is how are we heating our shops? And as you can tell, it's about 20 degrees in here in the barn. It's insulated, plywood walls, but there's insulation and everything. I have, you see the back of wood burning furnace that is, I just started a fire in it, and that takes a while to start heating up. So I know a lot of us go back to the old reliable Salamander. And this one's about 12 years old. It's lasted forever. 60,000 BTUs, and it runs off of diesel, kerosene, JP8, jet fuel, 1 and 2 fuel oil, and number 1 and 2 diesel. Well, same way with my tractor with diesel fuel, it's really sometimes hard not to make a mess when you're filling it. So I thought I'd do a review of both things, using this to heat the barn up quickly, and then using the wood burner to maintain it. And also how I'm fueling these now, filling the tanks, is with this Harbor Freight liquid transfer pump. And it's super cheap. I think it was $12 or something at the local Harbor Freight. So you don't really care if it breaks, and you don't have to keep it nice. But so far I've used this for about 2 months now, and it ends up going back to the same packaging. And it takes 2 D or C cell batteries. I think C cell batteries. But just wait and watch and see how easy this is. So I ran this Salamander out of fuel the other week, and I've got my diesel canister here. I'm sorry, it's so cold in here, I'm shaking. So you basically put the dip tube down into your canister, take your fill tube, put it right in there, and hit the switch. Look, right there, it's green. Filling right up. Now this here's a 5-gallon tank of fuel, and this takes just about 5 as well, maybe 4. But look how easy that is to control. And this is what I'm using on my tractor as well. I'll post a video at some point because it's just so much easier. Not having to hold the canister up, put a funnel on it. Okay, like I was saying, this is a 60,000 BTU or British thermal unit. That's the amount of degrees or of heat it is required to raise 1 pound of water 1 degree. A lot of science. Either way, this will heat the shop up quickly, although it does put off some fumes. So, take a little, get a little. That's why the wood burner is nice to keep it warm once it's up to temp. But to get it up to temp quick, these guys really work. Just as easy as a drop cord. Make sure it's out of the way of the flame. Make sure there's nothing you're pointing at that's flammable, because this is going to blow out that direction. Plug it in this way. Count to about 5. And there we go. Now, you can see it's running, or here it's running. This is what the outside looks like. Now, there is a little bit of fumes that you'll get. Pretty soon, the baffle there on the front will get red hot. But there, I can feel the heat coming off of it right now. You can see behind the baffle, the flame actually burning. So that baffle catches that, the fan blows across it, that's what you get for heat. Okay, well, let's talk about 3-phase power. Now, I'm in an agricultural setting. I brought in new power just to my barn, separate from my house. So I have a 200 amp service at the house, and I have a 200 amp service here in the barn. Now, that is single phase power. And what I mean by that is if you open up our panel here, we have 2 pots of 110. combined equal to 220 that some of our larger equipment runs on. Now this is single phase. So at your main breaker, just above the harness panel, you have two wires coming in, and you have a ground that goes outside the ground. What I did here is create a three-phase generator. That is the gray box over here. I'll show you in a minute. Above that is a Dayton heater that is three-phase also. I got from a friend. Single phase will not run that three-phase heater, nor my leg. So what we have done is I have brought a new branch down, all the way down. This here is our breaker, 30 amp breaker, and we're going to power it. Okay, shut that guy off. I don't leave this on all the time. Now this goes up, over, drops that down to our VFD, which we are going to convert from single phase power into three phase. So I picked up the Honeywell Home. This is the non-programmable style, cheap, easy. If I know I want to keep the barn at 50 degrees while I'm not in it, this is how I do it. Otherwise, you got to rely on batteries and whatnot. This is more of a manual thermostat. So let's get this unboxed and see what we're working with. Smart Solutions, Brilliant Home. Now look at that great packaging. Looks like it comes with some instructions and some mounting hardware. This is a heat only, not used for air conditioning. You have a mounting plate, the wiring lugs, and the thermostat itself. It looks like we mount the base, then the back, and our wiring will come in, connect here to the lugs. Then this guy just snaps on through a pin receiver right there into the housing. That easy. Okay, we're going to get this mounting plate and receiver mounted. Now this is an external thermostat wiring because it's on an external heater. If this was going in your house, the thermostatic wires would be coming through the drywall, but this will be a lot easier for us. Let's start on this project. I need to hook up a thermostat to this heater. I'll show you in a minute. But step one, we need to take the outer layer of our thermostat wiring, which this is just a 2-wire. So we're going to go ahead and clean that off with our pocket knife. Very carefully, we're going to strip off about 2 inches there. Just scoring the outside of the insulated cover. Now it's important not to cut yourself or go all the way through. That exposes our 2 wires to complete our circuit. Basically, the thermostat, here's the garbage. Basically, the thermostat will hold the temperature. When it drops below, it'll make contact, completing the circuit, telling the heater above to turn on. Our wire strippers, and this is like a (20 to 22) control wiring. going to take off about 1 inch, leaving the solid wire exposed. Do the same thing on the other side. Perfect. Now, if you can see, right here, there's some switches. They're covered with a piece of plastic, and they're saying, depending on the type of system here, where am I at? Here we go. Depending on the type of system, you can see right here, we have to have those switches in a unique position. So for electric, warm air, switch 1 is on, switch 2 is off. I'm going to take that plastic off, see if I can get those moved over. This is very difficult to see. So, as it says here for electric warm air, I need to set this thermostat switch 1 to on, switch 2 to off. The switches are right here, and the off position is closest to me. I'm using a jeweler's hook here, and since it's saying switch 1 on, switch 2 off, I'm assuming that 2 is down here, it's in the off position. Switch 1, there, I got pushed over to on. So I should be able to get this pin receiver onto the wall adapter and housing, and we should be able to work now. Now, I have my thermostatic wires coming through. As you can see here, we have our red terminal, white terminal. In a furnace air conditioner setup, you would have a third yellow. But we're only going to use the red and white. Now, I already have my wires here, red and white, so it should be fairly easy to get them connected. Opening the screw up, making room for your thermostatic wire, and then clamping it down into the lug by tightening the screw. Be fairly easy, nice and easy. On our white terminal, the same setup. I'm also pushing the wires over as I tighten them down, snugging it up so they're nice and organized. Now we're going to add the thermostat itself. As you can see, the receiver right here is for the pins right here. That should just snap into place. There we go. Now our temperature in here right now is at 50. And our set point is at 70. So we're going to set that down, and I'm going to show you how this thing's wired. Now, as you've seen in the past, my lathe is a 3-phase piece of equipment, and this is how I'm operating. So inside here, we have a VFD. Now, this VFD is a variable frequency drive. It is used on pieces of equipment that need to ramp up or ramp down the RPMs on a motor, fans, compressors, things like that. Now, the important thing is when your single-phase power comes in, right here, we have 220, 240 coming in. Inside this VFD, it's converted to DC power. And then on its way out, it becomes 3-phase. And that's the way this piece of equipment is set up. Now, what we need to do when we start this is make sure there we go, that we get this up to 60 hertz. That is the standard in the United States. Now, like I was saying, single phase coming in, it converts to DC power, then it's converted back, and we are generating a third leg. So let's give that a try. We are running. Now, what I have set up here, I just put a plug in, and this was originally for my lathe to operate it as a three-phase piece of equipment. What I also did is, since I have that plug, I want to use this VFD for multiple things. So I rewired this here, which is three-phase, put a nice heavy whip on it, and then just hooked up that thermostat. The second I turned that VFD on, this guy started cooking out some hot air. I can feel it already. That's going to be nice. Now my thermostat is set to 60, and I want to see if that will kick off once it reaches there.